Hello everyone, welcome to my channel CISC Topper Classes. Today we are going to discuss chapter 5 quadratic equation in one variable exercise 5.4 question number 1 to 7 of M.L.aggarwal class 10 mathematics. So let us start solving this exercise here in this video. Now let us solve here exercise 5.4. Find the discriminant of the following quadratic equation and hence find the nature of the roots here. We know here discriminant formula is b square minus 4ac. The under root part of the formula, quadratic formula, that is x is, we know the formula for quadratic, minus b plus minus under root b square minus 4ac by 2a. Hence this part is the discriminant in that. So if we have to find the discriminant, we will put the value of b here, that is minus 5 ka whole square minus 4 into 3 into minus 2. That will become 25 plus 12 into 3 here, sorry, 8 into 3. 8 into 3 equal to 25 plus 24 equal to 49 from that. So 49 is the value of discriminant here, and we know if value of discriminant is greater than 0, then it has two distinct real roots. Two distinct real roots is the nature of roots in this equation here. Now let us solve here question number 1 second part. We know a is equal to 2 here, b is minus 3 and c is 5. From that the roots, the discriminant value is b square minus 4ac equal to minus 3 ka whole square minus 4 into 2 into 5. That will become 9 minus 8 into 5 will be 40. So discriminant value is less than 0 here. And if discriminant value is less than 0, then we can say that it has, the equation has no real roots here, because if discriminant value will be in negative, the under root of that will be irrational number here, or that is not a perfect square. Hence from that the rule, we will get no real roots here. So this is the final solution of question number 1 second part. Let's solve here question number 1 third part. Here the value of a is 16, b is minus 40, c is 25. From that the value of discriminant we can write it as b square minus 4ac as minus 40 ka whole square minus 4 into 16 into 25. So here we will get the here minus, sorry, positive 1600 and here minus 1600 on calculating. This will be 0. If discriminant value is 0, we know we will get two equal real roots in this question as the solution. Sorry, two equal real roots here. So this is the final solution of question number 1 third part. Let us solve here question number 1 fourth part. The discriminant value we will find from there, that this will be b square minus 4ac. So here we can write it as 15 ka whole square minus 4 into 2 into 30. This will become here 225 minus 8 into 30 will be 240. And on subtracting this will become in negative. Negative 15 we will get, and we know if discriminant value is less than 0, then we will get no real roots in this solution. So this is the final answer of question number 1 fourth part. Let us solve here question number 2 first part. We know we have to find in this the nature of the roots. Here a is 3, b is minus 4 under root 3 and c is 4. From that the value of roots we have to find. So that will be d as b square minus 4ac 4 under root 3 ka whole square minus 4 into 3 into 4. That will become 16 into 3 minus 16 into 3 here. This will be cancelled out and we will get the value of discriminant as 0. Hence we will get two equal real roots in this question as the solution for x. Two equal real roots. So this is the final solution of question number 2 first part. Let us solve here question number 2 second part. If we write, it will become 2x square minus x plus 4 equal to 0, where a is 2, b is minus 1 and c is 4. So this will become, the discriminant value will be b square minus 4ac equal to b ka square will become minus 1 ka whole square minus 4 into 2 into 4. So 1 minus 8 into 4 will be 32 here. From there we get the value of d as less than 0. And we know if the discriminant value is less than 0, we will get no real roots here in solution for x. Hence, this is the final solution of question number 2, second part. Let us solve here question number 2, third part. If we multiply this whole equation with negative, that will become 2x square minus x minus 1 equal to 0, where a is 2, b is minus 1, c is minus 1. So discriminant will become b square minus 4ac as b ka whole square minus 1 ka whole square minus 4 into 2 into minus 1 equal to 1 uh, plus 8 here, that is 9. From there we get d is greater than 0, and we know if the discriminant value is greater than 0, we will get two distinct real roots in this equation. So this is the solution of question number 2, third part. Let us solve your question number 2, fourth part, where a is 2 under root 3, b is minus 5, c is under root 3. From that, the value of discriminant will be b square minus 4ac, that will be 25, minus 4 into 2 under root 3 into under root 3. So 25 minus 24 is equal to 1, and 1 is always greater than 0. From there, we will get it has two distinct real roots here, and this is the solution of question number 2, fourth part. Let's solve your question number 3, first part. Find the nature of the roots of the following quadratic equations. If real roots exist, find them. So we know if real roots we will get, then we have to find them also here. So firstly we will find that is the real roots exist here in this equation. So a is 1 here. Firstly, we'll take LCM to form a quadratic type. It will become 2x square minus x minus 1 equal to 0, where a is 2, b is minus 1, c is also minus 1. If we find the value of discriminant b square minus 4ac, it will become 1 minus plus 8. This will become 9, where discriminant is greater than 0. If discriminant is greater than 0, we can say that it has real roots. Means the equation has two distinct real roots here. And we know if real roots exist, we have to find them also in that question. So from that, 2x square, we can write it as minus 2x plus x minus 1 equal to 0. By factor form, we are finding the value of x here. If we take 2x common, it will become x minus 1. 1 common, again x minus 1 equal to 0. So x will be minus 1 by 2, or x is equal to 1 from that. Hence, this is the solution here of question number 3, first part. Let's solve your question number 3, second part. If we solve this part here, the value is a given to us as 1, b as minus 2 under root 3, c as minus 1. So discriminant will be b square minus 4ac. B square will become minus 2 under root 3 ka whole square minus 4 into 1 into minus 1 here. On taking a square, it will become 4 into 3, that will be 12 here plus 4. So this will be 16. Means discriminant value is greater than 0, and we are getting here also two distinct real roots. Now if we are getting real roots, we have to also find the solution. Also the roots also we have to find. So this part we can write it as a as given as 1, b is minus 2 under root 3. We will use here quadratic formula to solve this part. So that will be x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. If we put the value, this will become 2 under root 3 plus minus b ka whole square will be 4 into 3. So 12 plus 4 divided by 2. So 2 under root 3 plus minus under root 16 divided by 2 will be 2 under root 3 plus minus 4 divided by 2. From that, x is equal to 2 under root 3 plus 4 divided by 2, and 2 under root 3 minus 4 divided by 2 is the final answer here in this question. And this is the solution of question number 3, second part. And on more simplifying, we will get under root 3 plus 2 and under root 3 minus 2 as the answer roots here in this question. Let us solve your question number 4, first part. Here it is said that without solving the following quadratic equation, we have to find the value of p for which the given equation have real and equal roots. So if we see here, we have to find the value of p. And it is given that we have equal and real roots of these equation, and if d is always equal to 0, then only we will get real and equal roots. Hence we can say that if we find the discriminant as b square minus 4ac, we will put the value of d 0 here. B square will be 4 ka square, that is 16, minus 4 into p into 3. From this only we will find the value of p. So that will become 4 p into 3 equal to 16. 4 3 are 12. So 12p equal to 16. P will be 16 by 12. If we solve this part, this will be cancelled out by 8, 6, and this will be cancelled out by 8. This will be cancelled out by 3 and 4. So P is equal to 4 by 3 is the answer in the question number 4 first part. Now let us solve your question number 4 second part. Here it is given A is 1, B is P minus 3 and C is P. And we know here also we are getting equal and real roots only. So from that D is equal to 0, and if we find the value of D, that is B square minus 4AC, we'll put the value of D, that is 0. B square will be P minus 3 ka whole square minus 4 into 1 into P. So it will be 4P from here, and P square plus 9 minus 6P. So P square minus 6P minus 4P plus 9 is equal to 0. So P square minus 10P plus 9 is equal to 0. From that, by making it a quadratic equation and solving by factorization, we will find the value of P here. That is only we have to find here. So P square minus 9P minus P plus 9 is equal to 0. Taking P as common, it will become P minus 9 minus 1 as common, again P minus 9 equal to 0. So P is equal to 1 or P is equal to 9 is the final answer in this question, and this is the solution of question number 4 second part. Let us solve your question number 5 first part. Here it is given, find the value of k for which each of the following quadratic equation has equal roots. We know if we are getting equal roots, the value of discriminant will be 0. And formula for discriminant is b square minus 4ac. Here written b is 4k, c is k square minus k plus 2, and a is 1. So this will be b square will become 4k ka whole square minus 4 into 1 into k square minus k plus 2. So this will become 16k square minus 4k square plus 4k minus 8. So that will become as on solving, because the value of d is 0, we will put the value here as 0. Then this will become 12k square plus 4k minus 8 equal to 0. And on solving, we will cancel out firstly this part. It will become here 3k square plus k minus 2 equal to 0. So 3k square plus, we can write it as 3k minus 2k minus 2 equal to 0. On taking 3k as common, it will become k plus 1 minus 2k as common, again minus 2 only as common, that will become k plus 1 equal to 0. So from that, k is equal to minus 1 or k is equal to 2 by 3. So this is the final answer here in this question, means the value of k here. Now let us solve here. Question number 5 second part here. We have to find the value of k for which each of the following quadratic equation has equal roots here. So for solving this, we know this will be a is k minus 4 in this equation, b is 2k minus 8, and c is 4. And if it has equal roots of the equation, then discriminant will be 0 here. On putting the value here d as b square minus 4ac, we will get 0 as equal to 2k minus 8 ka whole square minus 4 into k minus 4 into 4. So that will become 16k minus 16 into 4 will be 56. sorry, 16 into 4 will be 64k here, so that will become 64 equal to 4k square on taking square here plus 64 minus 16 into 2, that will become 32 k here. So on solving we will get 4k square minus 32k minus 16k plus 64 plus 64 equal to 0. This will become 4k square minus 8, and this will be minus 48k plus 128 equal to 0. This will be cancelled out by 12. This will be cancelled out by 32. So k square minus 12k plus 32 equal to 0 will be k square minus 4k minus 8k plus 32 equal to 0. So taking k as common, we will get k minus 4 minus 8 as common, again k minus 4 equal to 0. So k minus 4 cannot be equal to 0. Hence we can write from here that k minus 4 will not be equal to 0, because if we make it equal, the value here, it will become 0, and this is not possible here. So we will put k as 8. On checking for k is equal to 8, we will find the value of roots here. So k is equal to 8, we will put as 4x square plus 2 into 4x plus 4 equal to 0. This quadratic equation we have to solve. So it will become 4x square plus 8x plus 4 equal to 0. X square plus 2x plus 4 equal to 0 as x square plus 2x here. Sorry, here it will become 1 only, because in cancelling it will become 1. So x square plus x plus 1 equal to 0. If we have to solve it, we will take x as a common, x plus 1, again plus 1 is common, x plus 1 equal to 0. So x is equal to minus 1 and minus 1 are the roots here. So this is the final solution of question number 5, second part, when k is equal to 4, k is equal to 8, sorry. So this is the final solution of this question. Now let us solve this question here. We have to find the value of m for which each of the following quadratic equation has real roots. So we know here if this has equal roots, then the value of discriminant will be 0, and formula for discriminant is b square minus 4ac. We will put the value of all the variables here. A is 3m plus 1. If we compare, b is 2m plus 2 and c is m here. On putting value, this is 0. B square will be 2m plus 2 का whole square here minus 4 into 3m plus 1 into m. So that will become as 4m 3m plus 1 equal to 2m plus 2 का whole square as 12m square plus 4m equal to 4m square plus 4 plus 8m here. So that will become as 4m square plus 8m minus 12m square plus minus 4m also, and this will be plus 4 equal to 0. From that we can write 4m square minus 12m square as minus 8m square plus 4 minus 4 will be plus 4m plus 4 equal to 0. On taking here or multiplying with negative sign in this whole equation, we will get 8m square minus 4m minus 4 equal to 0. Cancelling 4, we will get 2m square minus m minus 1 equal to 0. On taking factors here, we will solve it by factor method as 2m square minus 2m plus m minus 1 equal to 0. Taking 2m here as common, it will become m minus 1 plus 1 is common, again m minus 1 equal to 0. So m is equal to 1, or m is equal to minus 1 by 2 is the final solution of question number 6 first part here. So these are the value of m here in this question, and this is the solution of question number 6 first part. Let us solve this question here. Question number 6 first part, here we have to find the value of m. We know here a is 1, b is 2m minus 2, and c is m plus 5. And if equal and real roots, then discriminant value will be 0. We will put the values here in this formula so that we will get the value of m. D will be 0. B square will become as 2m minus 2 ka whole square minus 4 into m plus 5. So on solving this, we will get 4m plus 20 equal to 4m square plus 4 minus 8m. And on solving this, 4m square minus 8m minus 4m plus 4 minus 20 equal to 0 as 4m square minus 12m minus 16 equal to 0. This will be cancelled out by 3 and this will be by 4. So m square minus 3m, if we factorize it, we will get the value of m from here. So m square minus 4m plus m minus 4 we will get, and taking m here as common, it will become m minus 4. 1 as common, m minus 4 equal to 0. So m is equal to 4 here, or m is equal to minus 1 is the final answer here in this question. And this is the solution of question number 6, second part. Let us solve here question number 7. We have to find the value of k for which each of the following quadratic equation has equal roots. So we know if it has equal roots, then in this equation discriminant will be 0 and d is equal to b square minus 4ac. So we will put all the values. D is equal to 0, b square as k square minus 9 into 4 will be 36. So k square will be 36. From that we can write k is equal to plus minus 6 here. If we write again, if in this question it is asked also that if we have finded the value of k, then we have to find the roots of those values of k. So if we put firstly plus 6, that will become 9x square plus 6x plus 1. So it will become 3x square. We can write it as the whole square here as. So this will become 1 plus 3x ka whole square as equal to 0 in this equation. So we can write 3x is equal to minus 1 and x is equal to minus 1 by 3 two times here. So these two roots are there when we put k as plus 6. If we put k here as minus 6, it will become 9x square minus 6x plus 1 equal to 0 as 1 minus 3x ka whole square equal to 0. So 3x is equal to 1 and x is equal to 1 by 3 two times. So this is the these two roots are coming when we put k as minus 6 here. And hence final solution of question number 7 first part. Let's solve here question number 7 second part. Here also we know discriminant we will put as 0 and d is equal to b square minus 4ac. On putting all the values here, b square will be b is equal to minus 2k and a is equal to 1, c is equal to 7k minus 12. So d we will put as 0, b will be minus 2 ka whole square minus 4 into 1 into 7k minus 12 here. So that will become as 7k 4 into 7k minus 12 this side equal to 4k square this side. This will become 4k square. We will make it as a quadratic equation 4k square minus 28k here minus 8 and this will be 48. On cancelling this part we will get k square minus 7k and this will be cancelled out by 12. Minus 12 is equal to 0. And from this quadratic equation we will find the value of k, that will become k square as minus 4k minus 3k minus 12 equal to 0. Taking k as common here, this will become k minus 4 minus 3 as common, that will become k plus 4 we can write. If we put minus 12 this side, it will become plus, hence it will be plus only. So on taking this common as, we will get k minus 4 equal to 0 and k will become equal to 4 and k will be 3. On putting k is equal to 4, firstly we will find the roots of this equation here. If we put k as 4, that will become x square minus 8x plus 28 minus 12 will be 10 plus 10 plus 6 will be 16, so equal to 0 here. If we solve this quadratic equation, we can write this as x square minus 4x plus 16 equal to 0. Taking x as common, x minus 4 minus 4 as common, x minus 4 equal to 0. X is equal to 4. Uh, there are two roots here, 4 and 4. Both are equal here because it is said in the question they are equal, hence verified from there. And if we put k is equal to 3 and then solve for the equation, that will become x square minus 6x plus 21 minus 12 will become here 9. So that will be plus 9 equal to 0. Again on solving this, we will get x square minus 3x plus 9 equal to 0. Taking x as common, we will get x minus 3. Here also minus 3 is common, x minus 3 equal to 0. From that x is equal to 3 or x is equal to 3. So there are also two roots, they are coming, equal roots are coming in the equation. Hence question number 7 second part, this is the final solution, and this is the process to find k, and this is the process to find the roots here. Thank you for watching my video. If you like this video, don't forget to like, share and subscribe my channel.